In this video, I want to go into a bit more detail about the motor control board. So in a previous video, we discussed how the motor control board is connected to the baseboard using this 4-conductor Grove cable, and that's shown here as the red, as the orange line. So this cable here is this cable. Now this cable, the 4 conductors are power, ground, and the other 2 are a serial protocol called I2C. So I2C stands for Inter-Integrated Circuit. It's a communication protocol that's mainly used for communicating short distances within a product between a microcontroller and several devices. With I2C, there's always one master device, and you can have multiple slaves connected to the same bus. So in our application here, the master is the Raspberry Pi, and the slave is the motor controller. Now you can have multiple slaves on an I2C bus connected to the same wire, and the master can communicate with each of them independently as long as each of the slaves has a unique address. So if we wanted to have more than one motor controller board, we would need to have a way of setting unique addresses for each of the motor controller boards. So one reason why you might be interested in having more than one motor controller board is if you wanted to add additional motor controller boards so that you could use DC motors like this for controlling an arm or an actuator or a rotation assembly for a head. So the one that comes with the kit is intended to be used for driving the motors, but if you wanted to add additional motor controllers, you could do that to control other parts of your robot. So we need to, if we're going to have multiple motor controllers, we need to be able to set their addresses. So on the motor control board, there is this four position dip switch. Let's look at what that's used for. So the dip switch sets some behavior of the motor controller, including the address. So the switches are labeled switch 1, 2, 3, and 4. I got this little table here. Switches 3 and 4 set the address of the board. Now if you have 2 switches, you have 4 possible states, right? They can both be off, they can both be on, they can be on and off, or off and on. So with these 2 dip switches, you could have up to 4 motor control boards with unique addresses. So that's switches 3 and 4 on the dip switch. Switch 1 and switch 2 on the dip switch are used for reversing the direction of the motors. So this is motor 1 up here and motor 2. If a motor is not turning the direction that you need it to for your application, you can just flip the switch and the motor will change direction. One scenario where that might be useful is, let's say you have one of these motors controlling a joint on a robot arm, and you decide you need to add an external gear to reduce the speed of that joint. Well, adding that gear would change the direction that joint would move. You could just flip the switch here and it would switch the direction of that motor. One thing I need to point out with the dip switches, their state is only read when the motor controller boots up. So if the motor controller is running and you flip one of the dip switches, that change in settings won't take effect until the motor controller restarts. In the UI, in the web-based UI for driving the robot, there's a way that you can add a widget to turn the power on and off to the motor controller. That's useful just to have as an emergency stop for the motor controller, but turning the motor controller off and back on will cause it to reboot and read the new settings from the dip switch. So if you change a switch and you're frustrated that it's not having an effect, it's probably because you haven't rebooted the motor controller. One other thing I should probably point out, motor 1, which is the upper motor here in this picture, is intended to drive the right-hand side of your robot, and motor 2 is for the left. So the software that we provide for driving the robot needs those motors to be connected and hooked up on those sides of the robot. Otherwise the control would probably be backwards. when it comes to doing all of this wiring, especially when doing the power wiring into all of these modules, make sure that the battery is removed when doing any of that wiring. It's really easy, for example, when you are attaching the input wiring to this motor controller, to accidentally touch the wires together and cause a short circuit. Also, when you're hooking the power wiring up especially, it's a good idea to have the battery removed just in case you hooked something in backwards. So before applying the battery, or if you've been making changes to the wire before you connect the battery up again, double check your wiring just to make sure that you don't have positive and negative switched around. Many of these boards are not reverse polarity protected, so if you hook the power up backwards, you will fry the circuit board.